Hello and welcome to Mrs. Messiah's day one of Algebra 2 Direct. So today we're going to start with talking about the trig functions in right triangles. So before we get to that, it's important to review how to get rid of a square root or a radical. So what I did was I took each of those numbers and I simplified. I made a factor tree and figured out what times what gives you 75. But since 5 is a prime number, 15 can break up a little further into 5 times 3. 5 times 3 is 15. So then I'm looking at each of my prime factors, and I know that if I have the square root of 5 times 3, I look for a pair that's the same. They're going to cancel out and move outside the square root. Oopsies, that's a 5, not a 2. When I do that, that's the same as having like the square root of 25. 5 times 5 is 25, but the square root of 25 reduces to simply just 5. But I also have a 3 left over. So now I have 5 root 3. There's my simplified answer. Over here, I can do the same thing. I figure out what times what, and sometimes I just cut the number in half. So half of 242 is 2, and when I divide this by 2, I get 121. I also know that 11 times 11 is 121, so now I can figure out what is left under the radical. Since I have two numbers that are the same, those two numbers are going to cancel out and move outside of the square root. So now I'm left with 11 root 2, just like I have below. So that's how you simplify a radical. And now we can look at a couple of more examples. When you have a square root on the bottom, we have to do what's called rationalize the fraction. So when you have a number on the bottom here that is under the square root, you need to multiply by that same square root on the bottom and on the top. When you do that, you can simply multiply across. 6 times 5 is 6 root 5. And on the bottom here, this is the same as saying 5 times 5 under the square root. Those two numbers are the same, and it simply reduces to the number 5. Over here, we can do the same thing. When we multiply the bottom by the square root of 17 on the top and the bottom over here, we can simply take 8 times root 17, and we have 8 root 17 on the top. And then when I have the square root of 17 here and the square root of 17 here, that's like having the square root of 17 times 17. Two numbers that are the same cancel out and move outside the square root, which is why I'm left with 17 here. So now I have some you-try examples. You might want to pause your screen now, so that way you can come back and check your answers to see if they're right. Ready, set, pause. But really, try these. These are the answers that you should get. You can also pause it now too to check to see if you were right. We're going to move on. And if we look at a little bit more about radicals, we sometimes have radicals that are over the top and the bottom. When we have that, we need to just simply take that symbol of the square root and put it over the top divided by square root of the number that's on the bottom. So I go from one big square root over the whole thing to just a square root over the top number and a square root over the bottom number. When I do that, I need to figure out if it can simplify any further. In this case, it can. So the square root of 8 is the same thing as 2 times 4, but 4 breaks up further into 2 times 2. So I have a 2 here, 4 goes away because 2 times 2 gives me 4, and now I'm left with 2 times 2 times 2. I have a pair of 2's under the square root. Those go away and move outside. So now I'm left with 2 root 2 on top, and on the bottom, since I have the square root of 9, 9 is the same thing as 3 times 3. Two numbers that are the same That's like having the square root of 3 times 3, taking those two numbers that are the same, canceling them out, and moving it outside the square root, which is how we got 3 on the bottom here. Typically on a test or quiz, this is what you're going to want to write for your answer. This essentially is the same thing, but this is the simplified version. Moving on to the next example, we did the same exact thing here. We put the 5 under the square root and the 7 under the square root. Now remember, you can't have a square root on the bottom, but over here, that reduced nicely to just a 3, because 3 times 3 is 9. But here, 7 doesn't multiply by anything other than 1 in itself. So we got to get rid of that square root on the bottom. So what I'm going to do is multiply by the square root of 7 on the bottom and on the top, because if I do it on one side, I have to do it on the other. So what I can do now is I can multiply across on the top. The square root of 5 times the square root of 7 is the same thing here as it is over here. You can put them under the same square root, like this, but neither one of those two simplify to anything other than 1 and itself. So the top is done. So I'm going to leave the top as root 35, because that doesn't break down any further, like I said earlier with the 5 and the 7. 5 and 7 are prime numbers. They don't break up further into anything other than 1 in itself. So the top is done. And now looking back at the bottom here, I have 7 times 7, but they're both under the square root. That's like having the square root of 7 times 7. Here's our two numbers that are the same. They cancel out and move to the front, which is how I get just 7. And there is my final answer. The square root of 35 divided by 7. Okay, now it's time for a you try. Here we go. But really, pause the screen so that way you can try it. Alright, I'm going to show you how to do this one now. So, just like above, when you have a square root over the top and bottom number, we're just going to simply do the square root of 2 divided by the square root of 3. You can't have a square root of a number on the bottom here, so I'm going to multiply by that same square root on the top and bottom. The reason I'm going to do that is because I need to rationalize the denominator, meaning I need to make the bottom not have a square root in it. So if I have the top, now I have the square root of 2 times 3. That just happens to equal 6, and 6 does not reduce further than 2 times 3, so I can just leave it as the square root of 6 over the square root of 3 times 3, two numbers that are the same, cancel out and move to the front. So now I'm just left with a 3, and there's my final answer. Looking at the next example, this one's a little bit different. This one's actually very similar to like what we did with this one up here. So I have the square root of 15 over the square root of 36. Now if you recognize that 36 is a perfect square, just like how 9 was here, it reduced into 3 times 3. 36 breaks up into 6 times 6. 6 times 6 is 36. The square root of 15 is the same thing as 5 times 3, but it doesn't break up any further. So I'm just left with a 3 and a 5, just like how over here 2 and 3 didn't break up further, so I was left with a 6. So here 5 times 3 is 15, and I can leave it like that, square root 15 divided by the square root of 6, two numbers that are the same. They cancel out, and you're left with 6. There's your answer. And that is all for today. Tomorrow, we are going to talk a little bit about the Pythagorean theorem. Stay tuned, because I will also have a little homework review, answer sheet, I guess you could call it. So yeah, just to summarize, we talked about radicals, having a square root on the bottom and rationalizing the denominator, that's the number on the bottom. We did a couple of U-tries, couple more radicals, some more u-tries, and tomorrow, like I said, we will do a little bit more with the Pythagorean theorem. Stay tuned, because here comes some practice problems and homework. Woo!